I hope you're not sleepy now. My name is Willian. I'm a web software engineer in an eBay office in Berlin. I'm a member of Mozilla Tech Speaker. I'm a Brazilian, so I like football. I was cheering for you in the last World Cup. Who of you are... who of you are front-end developer or works with JavaScript? Okay, nice. Usually, I like to speak about the future of JavaScript and emerging technologies, but this time I want to do something different. I want to show you something that you can do right now. So this is the first time I'm doing this exactly topic here. So if you have an idea how to improve or you want to ask some question, who can lead me to another way of improving this, please reach me out after this. Okay, that's it. I present you. Okay, in this talk, I will present you our strategies that we have right now to iterate over collections in JavaScript, and how this evolve to Iterable protocol, and how this differs from the previous approaches. And I will give some hints and tips to give you opportunity to get crazy and deeply explore this amazing JavaScript feature. Why should we iterate, right? Like, when we program, there are some basic operations that it's nearly present in the majority programming languages. Things like assignment, comparison, expressions, conditionals are one of those. And when we need to repeat a certain set of operation over a collection of data, we do need to iterate over it. But how do we iterate in JavaScript? Before ECMAScript 5, we were used to do loops to iterate over things. We have like some main loop statements in prior ES5, which are for statement, do while, and a for in statement. So this is the most common use case to iterate over an array in JavaScript back in days. So I'll use this example throughout this section, so you can relate to the difference among the syntaxes. This piece of code sums each value of the collection array and print out the result. Note that the syntax for this is the for statement is a bit verbose, but it gives you a bit more control on how you want to iterate over the collection. And this is how we will do this using while statement. The principle is the same, but there is the initializer and the increment of the index. You have to do this manually. And in contrast to the while statement, we have do while statement, which is a bit different, since it guarantees that you execute the whole loop at least once, since the check is at the end of the statement loop. And we have the for in statement, which was very popular before the introduction of ECMAScript 5. What it does is, for each enumerable value on the object, it gets the key assigned to a variable, so you can use in a way you prefer. But there is a problem with this. In this example here, it makes the code look a bit more complicated, because if you have something in your prop type chain defined before you iterate over it, you have this value, since this will be enumerable as well. You will have this issue that you are appending the string after the number. And for prevent us to have such a problem, we need to wrap the has own property on the object method has own property to check if this is something that it's on the object or and not from the prototype chain. Okay, although loops are a handy tool to iterate over collections, usually we only do some sort of basic operations like log the content, create identity collection, or filter some entries out, and always iterate from the beginning to the end without stopping, right? So controlling these indexes and variables over on this for or general loop of statements can lead to some source of bugs. So with the introduction of ECMAScript 5, it was created some array methods that can help you to process this collection. You can do you can have some methods like for each, map, filter, or reduce. So coming back to our sum example, we could use this array for each here to achieve similar results. Note that the arrow, just to make it concise, I'm using arrow functions, but arrow function is the x6, okay? I'm just using this to make this concise. Or more interesting, we can use an array reduce method to sum up all reduce the number of the array to one single value. Okay, but what's the difference between this approach and use loop? Expressiveness is the word here. Before, it was a bit harder to read the code and reason about what you're doing with that loop. But with these ES5 array methods, I can easily tell that on the first example, for each value of the array, I'm sum up the value to the sum variable. Or in the second one, I'm reducing the collection to a value. This is super nice, but has some caveats. If I want to traverse, for example, a result of document query select all, or the arguments of arguments array of a function, or if I want to traverse a map or set, I need first to transform this whole collection into an array, so then I can use the array methods. And do you ever stumble across this piece of code? Can you guess what this could be? This is a normalized list of products, and it's very common in state management, like Redux. Usually, when we want to traverse this kind of data, we either try to, when we retrieve this data, have an array of the IDs. So then, instead of traverse this object, I traverse this array and get by ID. Or I need to use the object keys methods to iterate on this. Wouldn't it be nice if you have just one way to traverse collection, regardless the type of the collection? Iterables is the answer for this. But before understanding what it is in JavaScript and how it works in JavaScript, let me first show you how it works in other languages. So to better understand how Iterables works, let's take a look on the original concept of iterator coming from the Gang of Four pattern book. One of the behavior pattern described in the book is the iterator pattern, and it's described like this. In object-oriented programming, the iterator pattern is a design pattern which an iterator is used to traverse a container and access the container elements. So you have the separation from the container per se and the algorithm that traverses this container. Actually, I got this from Wikipedia. In our object-oriented language, we solve this by implementing iterator interface. But JavaScript doesn't have interface. How can we do that in JavaScript? The answer is in iterator protocol. The JavaScript protocol, the iterator protocol defines a standard way to produce a sequence of values, either infinite or finite, and potentially return a value when these values cannot be generated anymore. I will use TypeScript type definitions just to help you to get the picture. Later on, we will see some example of using this. So, an object that implements an iterator protocol has to meet some criteria. First, it has to have implemented next method. And this next method should return an iterate result, which is a key value pair with two keys. One is value, which you can return the next value, and the done, which is a Boolean that shows that this object cannot produce any more value. Okay, but what is iterable protocol? The iterable protocol provides a standard way for JavaScript to traverse a collection. And it has to fulfill a following criteria. It has to have a key called symbol iterator, and it has to return an iterator. And all of these collections are iterables by default: array, string, map, set, and type array. All the sets of type array. And all of these methods and constructors accept iterable as an argument. And all of this syntax operates over iterable. We will see on this talk for off, spread operator, and the structure assignment. Yield star is a bit more complex. I wish I could cover this one, but otherwise the talk will be like 1 hour longer. So that's a question, how to create a custom iterable. So let's create a function with an iterator, not iterable. Here I create a simple implementation of iterator protocol. It's a range function that does the following. You give like a min and max value, and then it starts to produce numbers from this mean to the max value. And here is an example how I can use this. Note that since I'm not, this is not yet iterable, I have to use this funny while loop to traverse over this data. But let's make this iterable, right? So to make it an iterable, I need to extend our range example to wrapping the returning function under the iterable protocol, using the symbol iterator method. And then now that I have an iterable, I can use for off to iterate over it. The for off loop works as the following. You have the left of the off a variable that will be the value of that loop, and then the right side of the off you have the iterable that you provide to iterate over this. So for each loop you receive the value, and for example in for in you receive the key, and for off you receive the value. So since I have an iterable now, I can use spread operator to spread the values in an array. Or I can use any syntax that accepts an iterable. For example, this one I separate the range to head and tail, and then I can print that out. But coming back to our range example, it seems that we have a lot of statements block here, and this piece of code makes tricky to reason about it, right? Because there are only one piece of logic and a lot of wrappers. Before we factor in this function, let me introduce a special type of function in JavaScript that can help us to achieve more concise code. The generator function is a special type of function that can pause in the execution each time you yield a value. But the most interesting part in this is when you execute a generator, you receive an iterator and an iterable. And based on this information, we will refactor our code as the following. So Look that now the single iterator is just a generator function that I can yield the value. And it makes easier to read, but wait, since this function isn't doing anything else that just returning the iterable, I can transform this whole function into a generator, right? And looks a bit more, a bit shorter. So what I can do with it? So now we start the part of a more interesting part, which is the iterables on steroids. So okay, let's work on this example, which by the way shows the first benefit of using an iterable, which is the ability to create arbitrary sequence of numbers. But I just said that we are working with iterables on steroids, right? So let's put in some steroids on it. To put everyone in the same context, on this piece of code, I'm filtering, like I'm generating a number between 10 and 99. I'm filtering out all the multiple of 4, then I'm doubling this number, and then I'm just picking the 5 first. Okay, let's create our own map, filter, and take that operates over iterable. So this is how we would create the map function. Note that I'm not returning the generator per se. I'm returning the execution of the generator that will gives you back the iterable. And this is how we would do for filtering out the values out of the iterable. And this is our take function. So I will explain how all of this will work very soon. Putting all together, this is just like a pipe function, just because JavaScript doesn't have a pipeline operator yet. So putting all of this together, this is how this function will look like. But the question is, what numbers this code will return? Nothing, because iterables are lazy. So in that example, I'm just pumping some pipes, but there is no water flowing through this pipe. I need to put something at the end that can start to pull the data from the bottom. So then, to fix that, we want to pipe another function to the end of the iterable pipeline that syncs the data. And now we have the result we want. Okay, since both codes does exactly the same thing, what's the difference between an array method and the iterable pipe? Basically, there are two. The first one, on the top, I can provide any iterable to the function pipeline without transforming into an array, right? But that isn't the case to the bottom one. The bottom one, I need to transform first to an array and then use the functions. And the second difference is better explained by animation. So using the array methods, I need to generate all the values first, which give me 19 elements. And then I will filter out all the items that are not a multiple for, that will give me around about 22 items. Then I will map all of those. And at the end, I will just take the 5 first elements, which is not the case of the iterable pipeline. Now comes the good part. Since it's lazy, nothing happens, as I told you, until we go to the sync step. When I go to the sync step, and I have the spread operator, internally the spread operator will call the next method of the iterable. And since the previous iterable is the take iterable doesn't have any value, so we'll call the next from the map, that will call the next from the filter. And then I will have the first item. So then I will pushing back this number, process this to 24, and Since the take doesn't do anything because this is just the first one, the number or the count number will be just 1, and then I pass this further to the sync. And once again, once I have this, I will call the next from this iterable. And then once again, I'll call the next from the top one to the top one to the top one until I have the number. And then down again, down again, down again, until I have the second one. Fast forward, this is the last number. And then in this step, the take will, that if criteria will match, and the take will return. So when a function, when an interval returns, it finishes it sends a signal down to the next function. So then I finish the spread operator and I have all of my 5. So the difference here, since the intervals are lazy evaluated, is that I will not run to this problem that I have in an array that I need to process everything and then just filter to 22 and then keep it processing. In here, I will only process 5 elements. Okay, is that all? Not yet. Here comes the last part of my presentation. I'd like to spend some minutes showing async interval. Different from the interval protocol, the async interval protocol was built to handling iteration over a series of async data. So the protocol has similar rules as the interval protocol with 2 major differences. The symbol that indicates that the interval is async interval is the symbol .async iterator. And it has to return an async iterator, which is most like the same as interval, but the next function returns, instead of the value, a promise that resolves the value. Okay, so connect the dots. You may ask, can I use the async generator for it? Yes, you can. Because when you call an async generator, it gives you an async iterator. Okay, how can I sync the async iterator, right? Because I have, since this is async, for off doesn't solve my problem because it's async, right? Okay, you can use for await loop. And the for await off loop works similarly to the for off loop, with just one difference. It supports async data. So on the right side of the off, you have you can use async iterable or a sync interval, because when you provide a sync data to the right side of for await off, it will under the hood wrap the value into a promise resolve. So it's kind of backwards compatible to the for off loop. What makes the async interval powerful, since like interval is lazy, is the ability to create pull streams. So this is different from the observables in JavaScript, because observables in JavaScript are push streams. So when you have an observable, you have a pipe of operators that operates over an observable, but then it pushes data down to this pipe as long as you have a bucket under this pipe. In async iterable is different. You have this pipeline of operators, and you only, it doesn't matter how much elements or data you have on top, if you don't start to pull data from the bottom, you don't have on any of this, which is it's a good example of how to handle the back pressure in the reactive programming, right? Because when you have observables, you need to handle back pressure, because sometimes you have more elements that you can process. But in async iterable, this is one. It makes a bit easier to handle this. Okay, Actually, there is a proposal on WhatWG, which is the committee that works on the proposals for the web platform alongside with the W3C. And that makes streams to be consumable as async iterators. So you will have, this will be the first example of building async iterables in the web. Okay, I hope I could call your attention with this ton of information, and I hope you're excited to research more about it, about iterables in general. There are some links. The first one I want to put a bit more highlight. It's proof of concept I made of creating a state management, side effect management for JavaScript only using iterables. Pay attention, please. This is not a new package. This is not a new framework. It's just a proof of concept, okay? You can check that out, and if you have some ideas that I can improve this, feel free. And there are tons and more research to learn more about it. These are my contacts. If you want to talk to me, follow me on Twitter, and my email there. And hvala.